Hello everyone. In this video I'm going to give you a solution to the whiteboard that we did on the second day of class. This corresponds to chapter C2 in the 6 Big Ideas physics textbook. So there's the setup for the first problem. We have a vector which is in the first quadrant, an angle, and we need to break this vector into components. In other words, we need to find what Vx and Vy are. Well, so I'm going to add those onto the diagram so we can visualize this a little better. Right there is Vx along the x-axis, and right here is Vy along the y-axis. So now using trig, I can just write down straight from the definition of the trig functions. The sine of theta is the opposite over the hypotenuse, and I put magnitudes on these because in this expression, these have to be lengths. Lengths are definitely positive numbers. They are definitely magnitudes. So I put the magnitudes on there. Cosine theta is adjacent over hypotenuse, again with the magnitudes. So now I can just rearrange these to solve for the components, where the magnitude of the x component is magnitude of v cosine theta, magnitude of the y component is magnitude of v sine theta. So now, since I actually don't want the magnitudes, I want the actual values vx and vy, I just have to ask myself, if I expect these to be positive or negative. Vx is along the positive x direction, I expect this to be positive, and this is along the positive y direction, I expect that to be positive as well, so I can just get rid of the magnitudes. And so my final answer looks like that, and I'm using the common convention that the magnitude of v denoted by bars can now just be written as v. I'm comfortable doing that. If you're not comfortable doing that, leave those bars on there, just to make sure that you are convinced that that's the magnitude of the vector and not the vector itself. So now that we've done this, it should be pretty easy to just blow through the other examples on this whiteboard because we've done the hard work. We just need to deal with the fact that some of the vectors are in different quadrants, and so we have some negative signs to deal with. So here's the second example. We have a vector w along with an angle phi. Again, I'm going to add in the vector components to make it obvious what I'm doing, just like that. And so now I can do my just write down my trig functions again, which is this: sine phi is the magnitude of wx divided by the magnitude of w, and cosine phi is the magnitude of wy divided by the magnitude of w. Rearranging these to solve for the components are like that. So the wx is now the magnitude of w sine phi, and y is cosine phi. So now we have to play the same game as I did before and check to see what the sign should be, because again, I want the components of the vector, not the magnitude of the components. Well, wy is fine. Wy is along the positive y direction, so this is a positive number, so I can drop out the magnitude with no problem. But wx should be a negative number because it is saying that the component along the x direction for w is negative. So then when I drop off these magnitudes, in order to make sure this is negative, I have to add a negative sign in. And so there's my final answer. The x component is negative sine phi, y component positive w cosine phi. And if I wanted to write this in a complete vector form, I could write the following. So now this is an actual vector with the unit vectors in there, and now I could just explicitly read off that this is wx and this is wy. Okay, so now I should just be able to write these results down. You should be pretty familiar with what I'm doing. Here's the picture and the components. And so now I have to play the game of the negative signs, and in this case, ax is definitely a positive number, ay is definitely a negative number, and so my final answer is the following. And again, if you want to put in the bars to make sure these are actually magnitudes, feel free to do that. Okay, so finally we have a vector in the third quadrant, so I'll draw the picture and write the components first. So by is b sine beta and bx is b cosine beta. Now when I analyze my negative signs, I see that bx has to be negative, by has to be negative, and my final answer is bx is negative b cosine beta and by is negative b sine beta. Okay, so that's the answer to this whiteboard. This is a skill that you're going to need to use on a daily basis in this class. So remember just some of the key points. The the way that you find the components, which trig function goes with each component, you cannot memorize x goes with sine, y goes with cosine, or even the opposite. It depends which angle is given and which component you're looking for. Second, make sure you get the negative signs right. If you want this to represent a magnitude, then you might need to put in that negative sign if the component is actually going to be negative. So those are the key points. Remember them, and thank you guys for watching.